Imagine you are trying to call your friend Amit. You open your phone's contact list. You start looking for his name. You scroll down checking each name one by one. This is exactly how linear search works. It's like searching for your friend's name in your contacts. You start from the beginning. You check each name one after the other. You stop when you find your friend's name, Amit. If you reach the end of the list and haven't found Amit, then you know he's not in your contacts. Linear search is like looking for a book in a messy room. You start from one corner and check each item one by one. You keep going until you find your book or you've searched the entire room. It's a simple way to find something. In computer science, linear search is a basic searching algorithm. An algorithm is a set of steps to solve a problem. Linear search is used to find a specific item in a list of items. This list could be anything, numbers, names, or even items in a shopping cart. You might wonder why use such a simple search method. Well, imagine you have a small unsorted list. Linear search is perfect for this. It's easy to understand and use. You don't need to arrange the list in any particular order. Think about it like this. If you only have a few books scattered on your desk, it's quicker to just look at each one. You don't need to organize them on a bookshelf first. Linear search works the same way. For small lists, it's a quick and straightforward solution. Section 4. How linear search works. A step-by-step guide. Let's say you have a list of numbers 10, 5, 8, 3, 2, 7. You want to find the number 3. Here's how linear search would do it. 1. Start at the beginning. Look at the first number, which is 10. 2. Compare. Is 10 equal to 3? No. 3. Move to the next. Move on to the next number, which is 5. 4. Compare again. Is 5 equal to 3? No. 5. Keep going. Repeat steps 3 and 4 for the remaining numbers. 6. Found it. You'll find 3 after checking a few more numbers. Now let's look at the pseudocode linear search list target. For each item in the list, if item equals target, return the index of the item, return -1 / target not found in the list. And here's the Python code. Def linear search list target. For I in range, len list. If listy == target, return, I return -1. My underscore list =, 10, 5, 8, 3, 2, 7. Target =3 index =, linear underscore search, my underscore list target, if index, =, print found at index, else print, target not found in the list. This code shows how linear search is implemented in Python. It checks each element of the list and returns the index if the target is found. Section 5. Linear search in action. Real-world examples. Linear search might seem simple, but it's used in many real-world applications. Contact lists. When you search for a name in your phone's contact list. E-commerce. When you search for a product on an e-commerce website. Internet of Things, IoT. Imagine a smart home system searching for available devices. Think of a smart refrigerator that uses linear search to find a specific item in its inventory list. It checks each item one by one until it finds the one you're looking for. Section 6. Weighing the pros and cons of linear search. Like any algorithm, linear search has its strengths and weaknesses. Pros: simplicity. It's easy to understand and implement. Unsorted data. It works perfectly fine on unsorted lists. Cons: inefficiency. It can be slow for large datasets. Imagine searching for a single grain of rice in a sack. It could take a while. Not always optimal. For sorted data, other algorithms are much faster. Section 7. Linear search, the first step in your algorithmic journey. Linear search is like the ABCs of algorithms. It's a fundamental concept that forms the basis for understanding more complex search algorithms. Even though it might not be the most efficient algorithm for all situations, its simplicity and ease of implementation make it an essential tool for any aspiring programmer or computer scientist. What are some other real-world scenarios where you think linear search would be a good fit? Share your thoughts in the comments below. And don't forget to subscribe for more exciting lessons on algorithms and computer science.